2017 marks Cassini's entry into Saturn's atmosphere, sending back new scientific data until the very end of its valiant 20-year mission. This dramatic ending is the culmination of Cassini's last 6 months of groundbreaking exploration, dubbed the grand finale. The start of Cassini's final orbits began on April 23, 2017. In many ways, even after 20 years in space, this seemed like a brand new mission for the probe. The first of these daring orbits took her high above Saturn's North Pole, flying just outside its narrow F-ring, and through the water-rich plume of Saturn's moon Enceladus. Then, in an attempt to squeeze even more great science, scientists figured out how to alter the craft's trajectory, bringing it dangerously closer to the planet than it's ever been before.
If we fly by Titan in just the right way, we can actually jump from just outside the rings all the way across the rings and dive through a gap in between the innermost ring and the top of the atmosphere. Now this gap is only 1,000 miles wide.
A task so bold and risky that it could only be undertaken at the end of its long and storied journey. As Cassini plunges past Saturn every 6 days, its cameras are giving us the first ever ultra-close images of Saturn's clouds. A gorgeous aurora at the South Pole, created by its enormous magnetosphere. And rings. Cassini took this series of photographs over a 1-hour time frame, just before turning the saucer-shaped antenna towards the direction of its trajectory, protecting the craft crossing Saturn's rings.
And you feel like you're there and you can reach out and touch the rings. And then that space between the rings and the planet, measuring the particles and fields and plasma, what's going on in that region.
These final dives are being used to reveal the mass of the rings, which will give scientists an idea of their age. Early findings suggest that they may perhaps be just 100 million years old, much younger than the 4.6 billion-year-old planet they surround.
Cassini is revealing Saturn from the inside out. With our gravity magnetic field measurements, we get to see inside the planet. How deep do the winds go? How's the magnetic field generated? What's the length of Saturn's day?
All this new knowledge comes at the tail end of a 2-decades-long journey of fantastic revelations that have rewritten the textbook on not only Saturn, but our entire solar system. And the discoveries just kept on coming. Saturn itself was ablaze with storms of unimaginable force. The place crackled with giant lightning strikes. The rings were even more dazzling than any had imagined, stretching across hundreds of thousands of miles. Yet sometimes only 10 feet thick. They're made of particles of pure water ice, some microscopic, some the size of mountains.
We used to think of rings as these individual particles kind of bumping into each other and sort of floating around in space. And we now know that the bulk of Saturn's main rings, particles actually stick together and they form these long strands that we call wakes, and that these wakes line up like the rows of a marching band.
They have grooves, if you like an old-fashioned record, created as wakes of moons, which are orbiting. Some of them, the moons are in the rings, some of those moons are outside the rings, and these waves give it an interesting texture.
They break apart and they reform, so there's this beautiful cosmic dance going on inside the rings.
All these years, Cassini had carried a hitchhiker with her, a little lander called Huygens, that was set to become the first probe to land on a moon other than our own. Because Titan had an atmosphere.
Titan has a really dense atmosphere, a denser atmosphere than here on Earth, nitrogen like here on Earth, but methane, natural gas, which is being converted into complex organic molecules by sunlight and radiation. And the chemistry that's occurring in Titan's atmosphere today may resemble what Earth was like before life evolved and created the oxygen we all breathe.
On Christmas Eve, 2004, Cassini cut the apron strings on the little Huygens craft, the brainchild of the European Space Agency. 3 weeks later, scientists around the world held their collective breaths as the little craft dropped toward Titan's surface. Huygens landed on the surface of what looked like a mud flat. The surface temperature was minus 350 degrees Fahrenheit, and these pebbles were made of methane ice. The nearby lake, a lake of methane.
And then Cassini went into orbit around Titan and revealed with his radar system that there indeed are lakes of liquid natural gas and other molecules on the surface of Titan. They evaporate, just like here on Earth, create clouds of methane which rain back on the surface.
And that's what created huge seas about the size of the Great Lakes on the Earth. Could there perhaps be some very interesting life in the lakes on Titan?
Like water on Earth, that rain had cut channels and gullies in the moon's surface. But there were dry formations here too, including dunes that stretched for miles and miles, reaching 100 meters high, and 3,000-meter mountains, suggesting tectonic forces at work here, similar to those on Earth. After the long-anticipated excitement of Titan, Cassini headed for a close look at a tiny moon called Enceladus. No one thought this shimmering little ball of ice, barely 300 miles across, could rival Titan scientifically, but they were wrong. Its sparkling surface is ridged and cracked, and seemingly scraped along its southern pole. Cassini's thermal sensors picked up heat coming out of the ice ball, 200 degrees warmer than the rest of the planet. Cassini captured giant jets of water spewing hundreds of miles out into space. They shoot out at 1,200 miles per hour, vaporizing and then freezing. Back on Earth, Cassini's stunned controllers quickly reprogrammed the probe to fly right through the jets, collecting particles. And what they found was even more stunning. Organic molecules, the basic building blocks of life.
Enceladus is really special. It's giving us free samples. And so Cassini has multiple times flown through. You can imagine it's sniffing the gas and getting coated with these icy particles, and some of them come in our sample and we know their composition. To our surprise, we found out that in looking at the particles, the ocean was salty. And it was salty and had a very similar pH to our own ocean here on the Earth.
Here on Earth, wherever there's liquid water, whether it's deep in the ocean and very hot or in rocky places or in ice, there's microbial life. So it certainly suggests microbial life could have evolved on Enceladus because it has all the properties that the Earth had when life began here.
As Cassini began to run out of fuel, making it unnavigable and unresponsive to trajectory commands, its team back home would have to take into account the possibility of life existing on one of Saturn's moons, with Cassini's fate hanging in the balance.
So, to protect these worlds for planetary protection, we decided to end the mission by going into Saturn's atmosphere.
September 15, 2017 marks the end of Cassini's bittersweet grand finale. NASA controllers are plunging the craft into the maelstrom of the gas giant, burning like a meteor in Saturn's atmosphere, guaranteeing it will be vaporized.
She'll be sending back data until the very last second that we want to know as we get deeper and deeper into Saturn's atmosphere. What's it made of? What's there? So we'll be gathered, I'm sure, with our Cassini family watching that tiny signal on the screen. And then as the atmosphere gets too dense, it will just turn her away, and then the end will come quickly. She'll be torn apart at a giant fireball going through in Saturn's atmosphere. And if you think about it, as she disintegrates and melts, her molecules will become part of Saturn. A very wonderful ending for this spacecraft. She studied Saturn, and her end is going to be with Saturn. She isn't just, bits of metal and wires and things. She's really the hopes and dreams of all of the scientists and engineers and all of the people who put it together.
September 15, 2017 marks Cassini's entry into Saturn's atmosphere, sending back new scientific data until the very end of its valiant 20-year mission. This dramatic ending is the culmination of Cassini's last 6 months of groundbreaking exploration, dubbed the grand finale. The start of Cassini's final orbits began on April 23, 2017. In many ways, even after 20 years in space, this seemed like a brand new mission for the probe. The first of these daring orbits took her high above Saturn's North Pole, flying just outside its narrow F-ring, and through the water-rich plume of Saturn's moon Enceladus. Then, in an attempt to squeeze even more great science, scientists figured out how to alter the craft's trajectory, bringing it dangerously closer to the planet than it's ever been before.
If we fly by Titan in just the right way, we can actually jump from just outside the rings all the way across the rings and dive through a gap in between the innermost ring and the top of the atmosphere. Now, this gap is only 1,000 miles wide.
A task so bold and risky that it could only be undertaken at the end of its long and storied journey. As Cassini plunges past Saturn every 6 days, its cameras are giving us the first ever ultra-close images of Saturn's clouds. A gorgeous aurora at the South Pole, created by its enormous magnetosphere. And rings. Cassini took this series of photographs over a 1-hour time frame, just before turning the saucer